Hello, ladies and gentlemen. Today we're going to take a little trip back in time to see just how many famous scientists got it wrong. Yes, I said wrong, but how their mistakes led to new discoveries for future scientists, who, you guessed it, also got it wrong. So kids, don't be afraid to make mistakes. Your mistakes could lead to the next great idea given by your classmate. Such is the case when we take a look at atomic theory. Well, what is atomic theory? It's the theory that all matter is made of tiny indivisible particles called atoms. And it all happened with some Greek philosophers so many years ago. Democritus, in particular, 2,500 years ago, proposed that all matter could be broken down to its smallest form, which would make it uncuttable. He called this atomos, which conveniently meant uncuttable. Now, if you're thinking, hey, atomos sounds a lot like atoms, I am too. Things that make you go, Well, he thought everything had its own atom that could be broken down into its smallest form, and bread was made of little bread atoms, and cheese of stretchy cheese atoms, and iron of hard iron atoms, and toilet paper, well, you get the idea. Did they have TP back then? I digress. The problem with his theories is that there was no scientific evidence to prove it. So you would think in 430 BC, with the beginning stages of atomic knowledge created, there would be research building on Democritus' ideas. Well, you would be wrong, at least for another 2,300 years. Fast forward to 1803, and British scholar John Dalton appears on the scene and agrees with the basics that Democritus has already proposed. All matter is made of atoms, all atoms can't be divided any further, and different elements are made of different atoms. All sounds familiar. He goes on to theorize how compounds are formed and chemical reactions take place. His atomic model is sometimes referred to as the bowling ball model, since the atom he pictures the solid, sphere, and the same throughout. What he lacked was also some scientific experimentation. Enter J.J. Thomson. He developed this cool cathode ray light bulb-like thingy. His experiments with the cathode ray were important because it proved that there were smaller particles than an atom. Psst, we call them subatomic. He noticed because the light wave would be attracted or repelled, so there must be both negative and positive particles inside of each tiny atom. His atomic model became known as the plum pudding model. Basically, he thought the pudding was the positively charged goo that the chunks of negatively charged plums were floating around in. Moving right along, this New Zealander, Ernest Rutherford, comes along only about 7 years later, and he does this gold foil test. Yes, like the kind of foil that covers your chocolate Easter bunny. And he finds that atoms are mostly empty space with a dense center where most of the mass is located. Whoa, mind blown. Thanks, Rutherford. You are my new favorite atomic theory scientist. His atomic model has the dense center of protons with negative electrons kind of flying all around. So, things are happening fast now in the scientific world, and just 2 years later, Niels Bohr decides that much like me, he likes the work of Rutherford and Thomson, and he decides he's going to work with them. He added on to their work by discovering that there were also neutrally charged particles in the center of the atom with the positive protons, and he used some fancy math formulas to calculate distances that the electrons moved around that nucleus. He theorized that the electrons traveled in neat orbits around the nucleus. That made him think of the planets circling the sun, and his atomic model became known as the planetary model of the atom, or the Bohr model of the atom. He wanted some cred, you know. Now, hold on to your uncomfortable classroom seats, boys and girls, because this is where atomic theory starts to blow your mind a bit. Two blokes in 1920 agreed on the last and current theory of the atom in which we use today in our chemistry and physics courses. They were Schrödinger and Heisenberg. They used a very confusing, which I will not pretend to understand, type of math called quantum mechanics. They were able to calculate some of the behavior of the electrons, and they found that, sorry Bohr, those electrons, they did not circle the nucleus in nice, neat orbital paths. They were rebels. They jetted all around that nucleus. There were areas that electrons were more likely to be found, and they used probability to describe those. Hey, that's a math I can do. Their atomic model is known as the electron cloud model of the atom, where the orbital paths are crisscrossing and the cloud drawn around the nucleus has lighter and darker areas. The rebels all hang out in the darker areas of the cloud. That is where they're more likely to congregate. So in conclusion, all of these philosophers, scholars, scientists, they were all a little bit right and a little bit wrong. And so it will go as time goes on. Modern atomic theory, while a little more involved, still has a solid foundation in Dalton's early theories. Now, with all your vast knowledge on atomic theory, you'll review my slideshow at your leisure and watch the video links that were omitted from this already too long video. You'll then use our modern atomic model to investigate the formation of compounds through the chemical bonding of atoms. Let the party begin.